REST API. What is a REST API? Well, think of REST API like a waiter at a restaurant. You tell the waiter what you want, they go to the kitchen, get it, and bring it back to you. That's exactly what a REST API does between your app and a server. REST stands for Representational State Transfer. Fancy words that basically mean a simple way for applications to talk to each other over the internet. REST uses the same HTTP methods you already know from web browsing. Get to retrieve data, like asking, "Show me all users." Post to create something new, like add this new user. Put to update existing data, and delete to remove it. Let's say you're building a social media app. When you want to show user profiles, your app sends a GET request to something like api.myapp.com/users/1. And boom, you get back all of John's profile info in a nice, clean JSON format. REST is stateless, means each request is completely independent. The server doesn't remember your previous requests, which means it can handle millions of users without getting confused about who asked for what. REST is also platform independent. Your iPhone app, Android app, web app, and even your smart fridge can all talk to the same REST API. But REST isn't formal enough for your bank transfers and enterprise systems. That's where SOAP API comes in. SOAP API. SOAP, or Simple Object Access Protocol, is one of the oldest and most formal ways that systems communicate with each other. If REST is like a casual phone call, SOAP is more like a formal business contract. Every message must follow strict rules and comes wrapped in XML with a very specific structure, an envelope to wrap everything, a header for metadata, and a body that holds the actual request or response. One of SOAP's strengths is that it's protocol independent. While it's most commonly used over HTTP or HTTPS, it can also run on SMTP, TCP, or other protocols. And because it has built-in standards for error handling, security, and transaction support, SOAP is often trusted in industries where reliability and precision matter most. That's why banks, healthcare providers, and government systems still rely heavily on SOAP today. For example, when you transfer money between banks, there's a good chance a SOAP API is working behind the scenes, ensuring the transaction is secure and correctly processed. SOAP might not be as lightweight or flexible as REST, but when you need guaranteed delivery, strict contracts, and enterprise-grade reliability, SOAP is the go-to choice. gRPC API. Before we talk about gRPC, let's step back to RPC, or Remote Procedure Call. RPC is the idea that instead of sending raw data over the network, your app can directly call a function on another machine as if it were local. For example, you write getUser123 in your code, and behind the scenes that request travels across the network, runs on the server, and returns the result. But early RPC systems like XML-RPC or JSON-RPC had problems. They were slower, text-heavy, and didn't scale well for today's massive real-time apps. That's where gRPC comes in. gRPC is Google's high-performance modern take on RPC. Think of it as the Formula One race car of APIs, built for speed, performance, and precision. While REST sends text-based JSON over HTTP, gRPC uses protocol buffers or protobuf, which compress data into a compact binary format that's lightning fast to process. It's like the difference between mailing a handwritten letter versus zipping all your files and sending them instantly. gRPC also takes advantage of HTTP too, allowing multiple requests to run over a single connection at the same time. And here's the best part. gRPC supports 4 powerful communication patterns. Simple request response, just like REST. Server streaming for live updates. Client streaming for sending continuous data. and bidirectional streaming, where both sides can chat at once in real time. The performance gains are massive, often 7 to 10 times faster than REST in many scenarios. That's why gRPC is the secret weapon behind systems like Netflix, Uber, and high-frequency trading platforms. GraphQL API. GraphQL stands for Graph Query Language, and it's about to change how you think about APIs forever. Created by Facebook, GraphQL is the game-changing query language that's revolutionizing how we fetch data. Here's the problem that GraphQL solves. In the case of REST APIs, you often get too much or too little data. Need a user's name and email? REST might send you their entire profile, address, preferences, and shopping history. That's called overfetching, and it wastes bandwidth. Or worse, you might need to make multiple API calls to get everything you need that's underfetching. GraphQL flips this completely. You write one query asking for exactly what you want, like just give me the username and email, skip everything else. One endpoint, one request, perfect data every time. But the killer feature of GraphQL is real-time subscriptions. Your app can listen for live update automatically. Plus, GraphQL is self-documenting with a built-in playground where you can test queries instantly. GitHub's entire API is built on GraphQL. Shopify and Pinterest all use GraphQL in production. If you're building modern applications where performance matters, users are on mobile devices, and you want to give front-end developers the flexibility to request exactly what they need, GraphQL might just be your new best friend. But sometimes you don't just want to fetch data. You want to be notified the instant something changes. That's where webhooks come in. Webhook API. Imagine this. With most APIs, your app is like someone constantly checking their mailbox. You walk outside, open it, see nothing, and walk back, over and over again. That's how traditional APIs work. Your app has to ask the server every time it wants to know if something new happened. But webhooks flip that model completely. Instead of you asking, the API calls you. It's like the mailman ringing your doorbell the moment a letter arrives. Instant, direct, and efficient. Let's see how it works. You set up a callback URL in your application. Whenever an event happens, like a new payment, a code push, or a form submission, the service sends a post request with the event details straight to your callback URL. No polling, no wasted requests, just real-time updates. That's why webhooks are often called reverse APIs. Instead of your app chasing the data comes chasing your app. You'll find webhooks powering nearly every modern application. Like, GitHub fires webhooks when new code is pushed. Shopify triggers them when an order is placed. Slack and Discord bots rely on webhooks for commands and real-time reactions. From automating workflows to keeping systems instantly in sync, webhooks are the invisible backbone of real-time web development. WebSockets API. WebSockets are like opening a permanent phone line between your app and the server. Once the connection is established, both sides can talk to each other anytime. Instantly, no more waiting for the client to ask a question like with traditional HTTP. Here's how it works. It starts with a handshake. Your browser sends a special HTTP request saying, "Let's upgrade this to a WebSocket connection." The server agrees, they shake hands, and from that point on, the channel stays open. This gives you a persistent two-way communication line, which is perfect for real-time applications. Unlike regular HTTP, where the client always initiates, WebSockets allow the server to push data to you the moment something happens. Think about getting a stock price update, a chat message, or a game event the instant it occurs. That's the power of WebSockets. And it's flexible too. You can send plain text, JSON for structured data, or even binary files like images and videos. WebRTC API. WebRTC, or Web Real-Time Communication, isn't just a single API. It's a full framework that enables direct peer-to-peer communication between browsers or mobile apps. And here's the magic. The data doesn't need to flow through a central server. That's why WebRTC powers things like video calls, screen sharing, online gaming, and instant file transfers, all happening right inside your browser with no extra software. Think about your last Zoom or Google Meet call. When you're talking, your video and audio are sent straight from your device to the other person's device. No server in the middle storing or processing your private conversation. It's direct and real-time. Behind the scenes, WebRTC takes care of the messy networking details. It figures out NAT traversal so devices can talk across different networks. It automatically negotiates the best audio and video formats, and it uses adaptive bitrate streaming, which means it constantly adjusts quality depending on your internet speed. The result? No server bottlenecks, faster communication, and smoother real-time experiences. That's why WebRTC is the backbone of modern video conferencing, real-time collaboration tools, and peer-to-peer apps.